Okay, so this is a slide I skipped yesterday, and I don't know if you remember from geometry that you learned about two special right triangles in geometry. One of them is a 30, 60, 90 triangle. Learning about 30, 60, 90 triangles. And the ratio of the sides in a 30, 60, 90 triangle are always the same. So I'm going to write it, so if you want to wait a minute, you can wait a minute, or we can leave it like this. But the ratio is always the shortest side. If the shortest side is x, the hypotenuse is always, remember, twice that, right? Always. So if the shortest side was 5, the hypotenuse would be 10. And then the other side, which is like the middle length side, the one across from 60 degrees, is always the shortest side times the bigger length. Now, we talk a lot about the unit circle in here. The unit circle is if it has a radius of 1. So if you change this x to a 1, you will notice that would become a 1, a 2, and just a square root of 3. But no matter what the length, this is why the unit circle works on everything. Because if we do sine, cosine, and tangent of these angles, these x's will always cancel out. So think about if I did sine of 30 degrees. Sine is opposite over hypotenuse. You would get x over 2x. And would just cancel, which means that no matter what the length of the side is, the sine of 30 degrees will always be 1/2. So the x is just 1. I kind of did horizontally here for some reason. But if I did the cosine of 30 degrees, what would the cosine of 30 degrees be? Just doing SOHCAHTOA here. 30 degrees is my angle. So cosine is adjacent over hypotenuse. And again, every time there's going to be an x on each one, so it's going to cancel. Well, but that would just be adjacent over hypotenuse. Let's just work here. That would be x radical 3 over 2x, or that's the same as radical 3 over 2. So the cosine of every 30-degree angle, no matter what the side length is, will always be the square root of 3 over 2. And what would the tangent of 30 degrees be? Yeah, because opposite over adjacent would be like 1 over square root of 3, because the x's would cancel, or that would reduce to square root of 3 over 3. Again, both of those are accepted. Square root of 3. Yes. It depends. You're getting dual credit for this class, right? So if you get your dual credit for last semester and this semester, theoretically, you shouldn't have to take any more math if your major has nothing to do with math, because you have 6 credits of math going into it. But it depends. It depends on the college, if they take the credit, and it just depends on what your college makes you do. If you're doing nothing with math and you have Math 136, which is last semester, and this class is Math 137, that should be above the introduction math that they make you take. But a lot of colleges also make you take a math placement test, which means even if you have these credits and you go into that math placement test and you test really low, they might still make you take their introduction. So you need to talk to your college about that. But hopefully the answer would be no. So I have lots of kids that told me they never had to take math in college because they had their dual credits or their AP credit. Tangent of 30 would be opposite over adjacent, right? So if I did x over x radical 3, that's where I got the 1 over radical 3. Oh, because if we rationalize it, remember that's where you multiply the top and the bottom by radical 3. And remember, both answers are okay. So if you left your answer like this, or you wrote your answer like that, like they're equivalent. If you type those in your calculator, you get the same decimal. And then I wrote these in order of like 45 degrees is between 30 and 60. There's no 45-degree angle in here. But you could do 60 degrees, and I hope that you see what's going to happen here. Because when we switch to 60 degrees being our angle, now the opposite side is x radical 3, and the adjacent side is x. So what happens when we take the sine of 60 degrees? Sine is opposite over hypotenuse. So what do we get for the sine of 60 degrees? Are we seeing that one up there on 30 degrees? Does it make sense that the cosine of 30 degrees is the same as the sine of 60 degrees? Because the opposite side just switched to the adjacent side, and the adjacent side switched to the opposite side. What about the cosine of 60 degrees? Cosine is adjacent over hypotenuse. And now the adjacent side is right here. So that's x over 2x, which is just 1 half. It's not a coincidence that that happened. It's the same triangle. We just switched what we're calling opposite and adjacent. And the tangent of 60 degrees, it's still these same two numbers. The opposite side and the adjacent side are still the same numbers. They've just switched. So now this is flipped over, right? Because now it's going to be opposite over adjacent, which would be square root over 1, which is just the square root of 6. We are going to have a no calculator part of our quiz, and the big part of the no calculator part of our quiz is knowing the ratio of these triangles. Knowing that you can do, if I say what is the cosine of 30 degrees, or in radians, I might say in radians, that would be the same as pi of 6. But you have to be able to tell me, draw your triangle, or memorize those values, and know what they are. The other special triangle that you learned about in geometry was an isosceles right triangle, which is a 45-45 degree triangle, right? So if it's isosceles, that means these two lengths, the legs are the same length. And again, it could be anything. So we could call it x. If this is x and this is x, Pythagorean theorem, it works out that this is x radical 2. Or again, thinking about this unit circle that we're going to talk about, if you change those to 1s, you get 1, 1, radical 2. The really cool thing is it works always if the x's just cancel out. So if I did the sine of 45 degrees, they're both 45, so it doesn't matter which one you choose. Both of them have an opposite of x and a hypotenuse of x over the square root of 2. That's just going to be the x's going to cancel. 1 over the square root of 2. Or if we rationalize that, right, I can say that's square root of 2 over 2. What's the cosine of 45 degrees going to be? It's the same thing, because the adjacent side is the same as the opposite side, which is square root of 2 over 2. And tangent of 45 degrees is my favorite function to take tangent of, or my favorite angle to take tangent of, because what happens when I take the opposite side over the adjacent side? Just 1, because it's just x over x, which is just 1. Some people have fancy calculators that when they type stuff in their calculator, it gives them answers like square root of 3 over 2, which is why we have a no calculator part of this test, because I want the playing field to be even, that you don't have ones to do that. My calculator gives you a decimal, which means when it says give me an exact answer and you give me a decimal, that's wrong, because I don't want the decimal. I want these answers, square root of 3 over 2, square root of 2 over 2. So this is going to be a really good thing to look at, and you're going to have to keep practicing this before we have a test. So, right, so 30 degrees in radians, if you did the conversion, right, you would multiply by pi over 180. So 30 degrees in radians is pi over 6. 60 degrees in radians, if you multiply by pi over 180, that's what, pi thirds. And 45 degrees, think about pi halves is 90 degrees, so half of that is pi fourths. On the no calculator part of your test, I could give you in degrees or radians. I hope you don't know what it is by converting it. Like, you could actually just do the conversion, right? That's not that hard to do by hand, but just know it's going to be on your homework today. The part I didn't put yesterday, 19 through 24, are just asking you questions like tangent of pi fourths, cosine of pi thirds. And so they're kind of doing the radians, but it's just using the special. I didn't put these up here, but we could also do secant, cosecant, and cotangent. If you know these, you just flip them over. Or you could actually do the ratios doing that as well. Okay? But it also means we can kind of go backwards and we can solve some trig equations out too. So, this is what I was supposed to do yesterday. This one says, find the value in degrees and radians without a calculator. Which means, again, when your homework says without a calculator, that's going to show up on a no calculator part of your quiz or your test. So I did harder ones than just sine, cosine, and tangent, because it's always harder if I give you secant, cosecant, or cotangent. But the great thing is, you can change it. If secant of theta equals 2, secant is the reciprocal of which function? Cosine. So if secant of theta equals 2, what do you know cosine of theta equals? Number one, you flip it over, is just 1/2. You gotta know that. You gotta know the reciprocal function. So cosine of theta equals 1/2. I want to know what angle has a cosine of 1/2. You can look right above you because it's there, but on a test you're not going to have that right above you. So you want to be able to say, all right, it's one of those special angles. Because I'm not allowed to have a calculator. It's one of those special angles. So 1/2. This is telling me that the adjacent side is 1 and the hypotenuse is 2. You only have two special triangles. It either is the 1, 1 radical 2 or the x radical 2, or it's the 1, 2 radical 3. Because the x's always cancel, right? I'm going to change them to 1, the x's. So if it's 1/2, I know it's in the 30, 60, 90 triangle. You've got to know which sides go where, right? So if this is 30, this is 60. 1, 2, radical 3. You learned in geometry that the longest side always has the biggest angle, the shortest side always has the smallest angle. So that's how I know where to put my numbers. 30 degrees is always across from the shortest side, which I'm calling 1 and 6. You double that, you get 2. And if you take 1 times the square root of 3, that means the middle one, because the square root of 3 is equal to 1 to 2. So if you know what's in the 30, 60, 90 triangle, you have a 50-50 guess at this point. It's either 30 degrees or it's either 60 degrees. Hopefully you don't have to guess, because you can look at that and tell me which one of those angles is adjacent over hypotenuse equal to 1/2. It's 60 degrees, because 60 adjacent is 1, hypotenuse is 2. Which means there's not a lot of work to show on these. It's kind of a lot of brain work, or it's kind of looking at your triangle and understanding what you're looking for. So the answer here is what angle, right? Theta, what value of theta has a secant of 2 or a cosine of 1/2? Theta. It also says in radians, so this is kind of good practice. If you don't know what your degrees are in radians, that you can practice doing that, and maybe you'll kind of get it, or if not, remember you can always take 60 times over 180, and again, this will be without a calculator, so you need to make sure you can simplify that without a calculator, and 60 goes into 180 3 times, so that's a either. So the same thing on this one. And again, for me, even though cotangent equaling 1, maybe you can see already what the answer is, but for me, I always go back to sine, cosine, or tangent, because those are easier for me. So if cotangent of theta equals 1, what does tangent of theta equal? Also 1. The reciprocal of 1 is just 1, but I just do better with sine, cosine, and tangent. So think about what tangent is. Tangent is opposite over adjacent. So which triangle am I in if the opposite over the adjacent are the same thing? Is it 30, 60, 90, or is it going to be the 45, 45, 90? It's got to be the 45, 45, which you might be saying, why are you even drawing this? Because if it's a 45, 45 triangle, what's the answer have to be? 45 degrees. Because both of the acute angles are 45 degrees. So just so you know, right now, on the quiz we're going to have this week, there's only 3 possible answers to questions like this. It's either 30 degrees, 60 degrees or 45 degrees, because those are the only special angles that we know right now. So you really have a 1 in 3 shot if you know what it's asking here. But we know that theta here equals 45 degrees, because you can know that it's 1, 1, radical 2, or x, radical 2. And in radians, if we multiply that by pi over 180, do the simplification if you don't know. But to me, if you know that 90 degrees is pi halves, half of 90 is 45, half of pi halves is pi fourths. So that was let me don't miss a point on this because you only do degrees and you forget about the radians. So that's something quick to check. Alright, so that takes a little bit more thinking. Alright, now let's talk about how to do this on a calculator. Because what if it's not 30 degrees, 60 degrees, or 45 degrees? There's a whole lot more degrees than that, right? And so now it says, use a calculator to find your answer in degrees and radians. And so yesterday we were typing in values of theta, right? So we were taking like the cosine of pi fifths, or the cosine of 72 degrees. Well, today we're trying to solve for theta. So think about, when we're trying to solve, if this was multiplication, we would divide to get theta by itself. If it was addition, we would subtract, because those are the inverses. So to get theta by itself, you have to do the inverse of cosine. And maybe you already know what that button is on the here. Remember our symbol for inverse is the -1? So if you took, not the picture this every time, just for you. If you took inverse cosine of cosine, that cancels out your cosines, so you're left with theta, is what you're trying to get by itself. But if you do that to this side, you also have to do that to this side. Which means, the shortcut here is, anytime you're solving for theta and they say use a calculator, you have to do the inverse button, which is the cosine -1 or the sine -1 on your calculator. On my calculator, it's just second or second cosine. I can look on yours to see what you get. Now it says in the correct mode, whether your mode's in degrees or radians, that's the answer it'll give you theta in. So I'm going to do degrees first. My calculator says degrees at the bottom, and I'm going to hit inverse cosine, second cosine, and I'm just going to type that in, 0.9848. And it doesn't say what to round to on this, so let's just round, we just round the 2 decimal places, I get that 10 degrees. Do you get 10 degrees? You got a weird decimal, I'm guessing, during radians, which you also need. 10.0025. Anybody? Sorry, I didn't pass my calculator. Or you didn't get it. Anybody else? Now it also says in radians, which means you have 2 options. One option is you could just multiply by pi over 180 like we've always done, or perhaps the easier option is just change the radian mode and do it again, and it gives you the decimal in radian mode. And on my calculator, it keeps that up there already. So I don't have to retype it in. I just changed it to radian, under mode, or that second button, BRG. Hit enter again. And I'm just going to give the decimal on this one. 2 decimal places. I'm going to say that's about 0.17 radians. And again, make sure you put your degree symbol on your degrees, and then you don't have to put anything. Questions on any of that? Try number 4. Round that to 2 decimals, that would round up to 60.3. Did you get that? I did radians first this time because my calculator was working in radian mode. Again, if it's asking you for both radians and degrees, make sure you get both. If it's asking for one or the other, make sure you're in the right mode. Make sure if you struggle using this calculator that you see me before a quiz, because I will not help you type in your calculator on that quiz. I'm trying to see if you know how to do it. Questions about that? If they give you theta, you just type it in. If you're solving for theta, you have to do it. All right, the other thing that we have is just solving for some triangles, which again is some stuff that you did in geometry. And if they give you a special angle, you could do this without a calculator, but I'll also show you how you can do it with a calculator. But it says a 10-foot ladder leans against the side of a house and makes a 60-degree angle with the ground. How far up the house does it reach? So the ladder is 10 feet long, and it makes a 60-degree angle with the ground. So house, and very nicely, right? You can make a triangle out of that. And then it's really important that we label things in the right spot. The ladder's 10 feet tall, so that means that the hypotenuse is the ladder. And it makes a 60-degree angle with the ground. So that means down here, with the ground, it makes a 60-degree angle. So there's two ways to do this, whether you have a calculator or you don't have a calculator. If you don't have a calculator, this is now a 30, 60, 90 triangle, which means if the hypotenuse is 10 feet, what's the shortest side going to be of that triangle? 5, because the ratio is x, 2x, x radical 3, which means that this is 10 feet, this is 60 degrees, so that means this is the shortest side. That means this is 5 feet. And it means I could say the other side of this, the height, how tall is the house? I know that it's 5 radical 3, because I know the ratio in a 30, 60, 90 triangle. So without really doing any trig, I can say, how far of the house does it reach? 5 squared root of 3. That's kind of a weird answer, but if you didn't have a calculator on a 30, 60, 90 triangle, this is what you're supposed to do. If you did have a calculator, you can just set up a trig equation to solve. Our theta is 60 degrees, and we're looking for this, which I'm going to call h or x. So think about what trig function would I use if I want the sides opposite, and I know the hypotenuse. What's the hypotenuse? Say 5 60 degrees is equal to h over 10. Is that true? Sine of angle opposite of hypotenuse. And if you had a calculator, you can just solve that for h, which means I would just multiply both sides by 10. And you can type that in your calculator. Those of you that have calculators that give you radicals in their answer, it might give you 5 radicals. My calculator is going to give you just the decimal. Make sure you're in degree modes. If you're in radians and you type sine 60, that's going to be a very different answer. You get 8.66 feet, which is exactly the same as if you take 5 times the square root of 3, it's 8.66. So, again, two ways to do that, whether it's with a calculator or without a calculator. As long as you get the answer, right? So that's where, like, I just wanted to show you this, because what if this was 47 degrees? If it was 47 degrees, that's not an angle that we know, so that's where you have to know how to set up the ratio there. That kind of leads us into the next question. Yeah, definitely without a calculator, you would leave it at 5. Another thing I throw in here is reminding you what it means to solve a triangle. Solve a triangle means find every side and angle that's missing. And in this, there'll always be 3 things missing, right? How many sides and angles total have you added up all the sides and all the angles? How many things do you have? All the sides of the triangle plus all the angles of the triangle are how many total things? 6 things, right? There's 3 sides and 3 angles. Sorry. And in a solving one, they'll always give you 3 things. They'll always either give you 2 angles in one side or 2 sides and 1 angle to solve that. And so you're only finding 3 things. If it helps, you can like label what you know. So like I like to say, if this is little a, I'm going to call this angle big A. This little b, I'm going to call this angle big B, and then I always call the hypotenuse little c, and the angle across from the triangle. You don't have to re-say what they give you, but if you want to, you can, right? But what you have to tell me are the 3 missing parts. What's one missing part you could give me pretty easily here without having to do any tricks? Yeah, because what do we know about the angles of the triangle? They equal 180, right? So all you have to do to find angle A is subtract 180 or subtract 968 to get the angle. So we can say that we know angle A equals 22. Now when you're missing 2 sides of a triangle, you have to do trig to solve for one of those sides before you can do something else. Then we can talk about it later. So now you have choices. You can choose to solve for A first or to solve for B first. It doesn't matter. You could choose to use 68 degrees that they gave you, or you could choose to use the 22 degrees that you found. It doesn't matter. As long as you set it up correctly, you're going to get the right answer. For me, I always use what they gave me, because in case maybe I subtracted wrong, I don't want to get the wrong answer because of that. I don't do that. So I'm going to use 68 degrees, and I'm just going to start with A. So again, how do I know which trig function to use? I look at the angle that I'm using, and then I look at the side I'm trying to find and the side that I know. So if I look at 68 degrees, is A the opposite or the adjacent side to 68? It's adjacent, right? Because it's right next to, and I know 25. 25 is the hypotenuse. So which trig function do I have to use if I'm looking for the adjacent side and I know the hypotenuse? Cosine. I'm just going to set that up. Instead of cosine of theta, I'm going to say cosine of 68 degrees. And it equals the ratio, which is adjacent, over the hypotenuse, which is 25. 68 degrees is not in my special triangle, which means this has to be a calculator problem. Like, I can't do it without a calculator. And then I'm just solving it. So I'm going to multiply both sides by 25, make sure I'm in degree mode, and I'm just going to type that exactly in my calculator. 25 times the cosine of 68 in degree mode, I get 9.9. So I found angle A, I found side A. Now you have even more options. If you know 2 sides of the right triangle, could you just do Pythagorean theorem to find the third side? Definitely. Could I set up another trig function to find the third side? Definitely. It doesn't matter to me. I'll tell you that for me, I do trig over Pythagorean theorem because to me it's less work than squaring and subtracting and square rooting. But it doesn't matter to me, as long as you're doing one of them correctly. So for me, to find angle B, it's the exact same problem, except for now, 68 degrees compared to B, this is now the opposite side, right? So instead of cosine of 68 degrees, what could I set up? I could say the sine of 68 degrees equals the opposite side, which is B over 25. Since I have a calculator, to me, this is easier than Pythagorean theorem. But it's not wrong if you said 9.4 squared plus b squared equals 25 squared, and you subtract it over and you take the square root. I also like doing trig over Pythagorean theorem because 9.4, it really wasn't 9.4, right? Like, it kept on going. So the fact that we cut that off, and now we'll use it to find b, means that we might get a little bit different answer than if we do the trig way, but it should be similar. So if I did this, I get, if I round to 1 decimal, 23.2. Really quick way to at least check to make sure your answer makes sense. Remember, the hypotenuse has to be the biggest side. So if this was bigger than 25, you know you've done something wrong. Also remember, the shortest side is across from the smallest angle, so you kind of want to always make sure that that at least makes sense in your problem. Yes. Oh, totally. Yes, yes. So she set up she used 22 degrees and 68 degrees and said the cosine of 22 degrees equals 0.25, and you should get the exact same answer. Yeah. So I was just checking with the Pythagorean theorem way, I got 23.15, which also rounded up. So it should be pretty similar no matter which way you do it. But there's just lots of ways to do it. So my advice to you, especially on quizzes or tests, show me a little bit of work, because if you don't show me work and you got the wrong answer, I don't know how you did it. So I can't give you partial credit if I can't see what you did. Okay? I got one more problem on there, and again, it was just to show you that if it's a special angle, you don't necessarily have to do the trig, but you could do trig, and that would also work. But if this said without a calculator, that means an exact answer, or the direction said give an exact answer. And so I really want you to see those special angles. When you see 30 degrees, 60 degrees, or 45 degrees, I want you to realize, oh, that's the special triangle. What would it be if I wanted to solve this? And so, for the connection, what does the hypotenuse compare to the side length? And so in this case, x is 17, which means if you know your special triangle, you don't just show any work on this. It's just 17 squared 2. And so that's why knowing these special triangles is very helpful to us. Let's say you didn't know it and you were allowed to use a calculator. You could do just like the last problem, and you could say, well, 45 degrees, if they use 45 degrees compared to here is adjacent. This would be hypotenuse, which means you could say that cosine at 45 degrees equals 17 over r. That's a little bit more work to solve for on that one, right? I did solve that. I need to get r out of there, right? Can I multiply by r? R over, and then divide by cosine. And again, unless you have a calculator that gives you radicals in your answer, this means you're going to get a decimal. And so if it said without a calculator, or it said give an exact answer, then you're expected to do it without there. But I think if you do this, you get 24.04. I think 17 times the square root of 2, I get 24. Which means it's the same thing. I'm trying to get you to realize if you know these ratios, it makes life a lot easier. You have to know these ratios. We have a no part of our quiz. Okay? So, remember that I kind of switched up the homework yesterday, which means day 2 on your homework sheet says this. 42 through 57 multiples of 3, 61, 62, and 69. I also want you to add 20, 22, and 24. Yesterday it said 19 through 24 all. That was 6 problems. I just put half of them on there, but I really want you to do those as well. So, know we've kind of adjusted the homework sheet, but we're still covering the same amount. I'm at an SAT workshop tomorrow. I know you're really jealous, but you don't think about it too much, especially if you have a 2 hour which means I'm going to record going over some examples for this, and I'm going to leave a worksheet for you. And that's why I'm kind of unsure of whether the quiz is going to be Thursday or Friday. I'll make that decision and let you know tomorrow. But if the quiz is tomorrow, I'm going to give you a page that says, like, study this. These are the things you know with the calculator. These are the things you know without a calculator. And if I decide to push it back a day, then we'll have to review it. But either way, I'll give you a little page. And the worksheet will be a thing. The worksheet tomorrow is over both 4.1 and 4.2, which will be a nice study guide. Okay? So that means I won't be here in the morning because I'll be